Assalamu alaikum everyone. Today we have to start this chapter number 10, which is the last chapter of this course. And in this chapter, we will try to see the profitability analysis by using the cash flow diagrams, and we will see some of the more formulas that we can actually use to see the profitability of any plant and the cash flow diagrams of any project. Okay, so let us start and see what we have in this chapter. So the typical cumulative cash flow diagram for evaluation of the new project. So this one is basically the typical cumulative cash flow diagram for any project. So let us see what we have in this diagram. So in the year zero, when you are going to build a plant, so first of all you have to purchase the land. So there will be some investment in the land. Then you will purchase some equipments, and then you install that equipment and all of those things. So at the end of year two, your plant is ready, and then you have to put some additional money, which is the working capital, to start up the plant. Okay, so at the end of year two, you have to input the working capital, and after that one, you start production, and the revenues are being produced, and the sales are going on, and so on. Okay, and then you would see that what is the lifetime of the project. So usually the 12 years which is represented here minus 2 years from the actual operational of the plant. Okay, so 12 minus 2, that represent you the project life for the calculations. And here you would see the depreciation allowance that would cease at the end of year 8. Okay, so we have seen that IRS is the company that give you the lifetime of the equipments, and here we have specified the lifetime to be 6 years. Okay, so 8 minus 2, it will be 6 years here. 1 2 3 4 5 6 years that will allow you to get the depreciation allowance, and after that you have to pay the full tax. Okay, now once you have completed the lifetime of any project, then you can recover the salvage, which is the scrap value of the fixed capital investment. Then you can also recover the working capital that you have input at the end of year 2, and then you can also recover the cost of the land that you put here. Okay, so at the end of lifetime of the project, you can have these recoveries from the project. Okay, so this one is a typical cash flow diagram for any project that could be used to see the profitability of any project. Okay, we will see some of the more terms in this cash flow diagram as we proceed in this chapter. Okay, now a typical cash flow diagram for evaluation of a new project. First of all, you have to see the project life. Okay, so it is required for evaluation of the profitability of any project. So project life that you can see here, you have to see what is the project life, and that would impact the profitability of the project. Standardization of the project life when comparing different projects. So if you are having different projects, then you have to standardize the results to see the actual profitability from any project. Then project life of 10, 12, and 15 years are commonly used. So typically the lifetime of the project, it can be estimated between 10 to 15 years, and in the real life you would see maybe the actual project life goes up to 30 years. So after that time, or after 10 to 15 years, there is like the huge maintenance that is required as a running cost of any process. Okay, so you have to include that one. So whenever we make the analysis to determine the project feasibility, so the typical life that we specify for the analysis, it is between 12 to 15 years, but it will not represent the actual working lifetime of the project, because it can last for maybe 25 to 30 years. Okay, so it is for the analysis and to see the profitability in 10 to 15 years. Okay, now, time value of the money has to be considered when evaluating the profitability. So we have seen the concept of the time value of the money, and we see that $1,000 today will worth less $1,000 that you have after 10 years. Okay, so we have to also consider the time value of the money, and we have seen this concept a lot in the depreciation calculation. And we saw that why do we depreciate so quickly to save the amount of money that we need to give into the returns, or the in terms of taxes. Okay, so we have seen this concept earlier. Now, profitability criteria for project evaluation. There are three bases of evaluation. First one in terms of time, then in terms of cash, and then in terms of interest rate. Okay, so we will see all of these three evaluation bases for any project one by one. Okay. Now, for profitability criteria, it can depend on the non-discounted prices and the discounted prices. Now, what are the discounted prices? Non-discounted method do not take account of the time value of the money. So in this method, we will not include the time value of the money, and it is not recommended for evaluating new or large projects. Okay, so this method we will start from this method, non-discounted method. So the problem in this method, it will not account for the time value of the money, and this method is not recommended for evaluating big and the large projects. Okay. Now, in terms of the time criteria for the non-discounted profitability, first one is the payback time or the payback period. Okay, so it can be represented by PBP, which is time required after startup to recover the fixed capital investment, FCI, for the project. Other names of payback period, it is payout period, payoff period, cash recovery period. So the shorter the payback period, it is better. Okay, so for any project, you have to see the payback time, payback period. So the shorter the payback period is, the better the project is. And now the second case or the second method in terms of the cash criterion, it represents you the cumulative cash position and the cumulative cash ratio. Now for the cumulative cash position, it is the worth of the project at the end of its life. So we'll see this one. What is the worth at the end of any project? Okay, it is difficult to compare projects with dissimilar fixed capital investment, and sometimes it is difficult to compare different projects having different fixed capital investments. Now, cumulative cash ratio, it is basically the ratio of sum of all positive cash flows divided by sum of all negative cash flows. Okay, so we will see this one here. Okay, when we see this diagram here, so you can have this one cumulative cash ratio, which is 1 plus cumulative cash position divided by land plus working capital plus fixed capital investment. So this one basically represent you the cumulative cash position. Okay, and you can use this one cumulative cash position that you have at the end of 12 years. Okay, so this will give you some value which is a cumulative cash position. You can use in this equation to get the value for the cumulative cash ratio. Okay, now here you can see that there is a payback period. Okay, so we talked about this payback period. So this is the time in which you can recover the fixed capital investment from the project. Okay, so the shorter the payback time, the better the project is. Then we have one more equation. Let's see that one. Okay, so if the cumulative cash ratio, it is greater than 1, it implies that the project is potentially profitable. Okay, so if the value for this CCR is greater than 1, then we can have the better potential in the project in terms of profits. Okay, now the third one, interest rate criterion, which can be represented by rate of return on investment, ROROI. So it is equal to average annual net profit divided by fixed capital investment minus 1 by n, and represent you the number of years. So the higher the value of the rate of return on investment, it is better. Okay, so if you are getting more higher value for the rate of return on investment, we can have the better project feasibility. Now here we can see again, and this one is the cumulative cash position that you can have at the end of the project. Okay, then you can estimate the cumulative cash ratio using this equation, and using the rate of return on investment, you can actually use this equation. You can use the slope of this line. Okay, the dotted line that you get here, divided by FCI minus 1 by n. So this will give you the rate of return on investment. Okay, so if the slope is not given to you, then maybe the table will be provided to you where you can get the value for the numerator. So we will solve one example today, and we will see that how we can get the value from this graph or from the table. Now let us solve this example here. So a new chemical plant is going to be built and will require the following capital investment. All figures are in million dollars. Okay, so the cost of land it is $10 million, and the total fixed capital investment it is $150 million. Fixed capital investment during the first year it is $90 million. Fixed capital investment during the second year it is $60 million. Now the plant will start up after year two. Okay, so we can have this one. Working capital can be taken as 20% of the fixed capital investment. So 20% multiplied by 150, so you can have the $30 million requirement as a working capital at the end of second year. Okay, so let us see this one maybe from the graph here. Okay, so in the first year, in the year zero, when you're making the investment, so this is the part where you can have the land purchase. Then from this one to this one, it represents you the fixed capital investment, and you see that you're investing the money, so all of the things or the numbers are in negative. And then from here to here, at the end of year two, you need to have the working capital that you put here, which is the $30 million that we calculated. Okay, after this one, we can have the production and we can have the sales and we can have the positive slope in this one. So let's see this one also. uh, okay, so we have the working capital here, then the sales revenues and the cost of manufacturing are given below. So the sales, yearly sales are given as $75 million. Cost of manufacturing, excluding depreciation allowance after startup, it is $30 million. Taxation rate it is 45%. Salvage value it is $10 million. And the method for the depreciation that we would use here, it is a marks method. So we have one table in which we were provided with the percentages that we can use to estimate the depreciation in each of the year for the period of maybe the 5 or 6 years that is given to you in the table. Okay, now here the project life is assumed to be 10 years, so it is also given to you. Now calculate each non-discounted profitability criteria given in this section for the plant. Okay, so we have to calculate this one, rate of return on investment. We have to calculate the cumulative cash position, cumulative cash ratio, payback time, and so on. Okay, so for this one, keeping in view the data that we have in this example, we have to draw the table that can represent these results. Okay, now this table is very important to understand, and you should be able to make this table by yourself also. Okay, so we have to see this one year by year. So the total time of the lifetime of the project it is 10 years, and 2 years we need for the building of the plant. Okay, so here you can see here for fixed capital investment during first year, fixed capital investment in the second year, and the plant it can start at the end of year 2. Okay, so what we can see from this one, okay, at the year zero we have purchased the land $10 million. Then the year one we spent $90 million, and then year two we spent it how much, $60 million, and then again we spent like $30 million at the end of year two, which is the working capital. Okay, so in the year zero we spent it $10 million. In year one we spent it $90 million as a fixed capital investment. In the year two we spent it $60 million as a fixed capital investment, and $30 million as a working capital. So that's make the $90 million. Now we can have at the end of year two we can start the production. Okay, now we can say this one, after year two we have to use the depreciation by the marks method. So this one you can multiply here with the 20% of the fixed capital investment, and you can get the $30 million. Then you multiply with the 32% here as given in the marks table that we studied in the previous lecture, and so on. Okay, so here we can multiply this one with 5.76%, and we get the depreciation of $8.64 million. Okay, so once you have the value for this depreciation in these 6 years, now we can actually calculate the fixed capital investment minus sum of the depreciations that will actually give you the booking value. Okay, so the booking value at the start of project it is $150 million, no depreciation. Again for the first year it is $150 million, and for the second year there is also no depreciation here. And after that one, from the year 3 where when we can actually start running the plant, there is a depreciation of $30 million, and we will take the difference here, 150 minus 30, that will make 120. Then again 120 minus 48, it will give you 72, and so on. Okay, now at the end of year 8 we have completely depreciated the plant. So the value for the FCI, it will become 0, and this one minus this one 8.64 minus 8.64, it will become equal to 0, and after that there is no depreciation, and you have to pay the complete tax. Okay, now here the revenue, you can see from the year 3 we can have a revenue of $75 million per year. So you can have $75 million throughout. Okay, and at the end of 12, we have to add $10 million in $75 million, which will represent you the addition of the salvage value that we specify at the start of the project. Okay, so 75 plus 10 will make the $85 million. Now let us talk about the cumulative cash position. Now the cumulative cash position will give you the value that we have calculated here as $170.5 million. We actually here represent you the cumulative cash position. Okay, so this is the value for the cumulative cash position that you would get from this table here, which is equal to $170.50 million. Okay, now let us see what we have to calculate. First thing, we have to calculate the payback period. Then we have to calculate the CCP, cumulative cash position, and then we have to calculate the cumulative cash ratio, and then finally we have to calculate the rate of return on investment. Okay, so let us see how we can do this one. So first of all, we have to see that what are the things that we can recover at the end of the project. Okay, so we can recover the land cost, we can recover the working capital. Okay, so that makes a 10 plus 30, which is the $40 million. So it is the amount of money that we invested at the start of project, and we can recover here at the end of the project. Okay, so this wise that you can see here, it basically represent you the land cost and the working capital cost. Okay, and then the rest of the things, we have to see that how we can get the value for the payback period. Now the payback period from this graph, you can see that it is 3.85 years. Okay, so this one is from the year 2 we have started running the project, and then we have to see that how much money that we have recovered as a $150 million, which is the fixed capital investment. So there is from there we can actually get the value for payback period, that comes out to be 3.85, in which we have recovered $150 billion. Okay, the alternative way, we have to use the equation and which we can recover the payback time. So you can go back to this table here, and here what you can see, so the actual working of the plant, it started at what time? After the year 3. Okay, so you can see from here. Okay, so this one is a cumulative cash flow and this one is a cash flow. So in the first 3 years you have to add the terms here. Okay, so if you add 38, 46 and 37, it will give you $122 million. Okay, and if you add the fourth term here, it will exceed $150 million. Okay, so one thing we can be certain from here, that the value, it should lie in between the year 5 or 6, or if you start the actual operation of the plant at the year 3, then 1 to 3 years would be the actual cash flow, and the fourth year in between, like 3 to 4 years, you can recover $150 million. Okay, so you have to see this one. For the 3 years you can recover $122 million, and before the fourth year end you can get the $150 million completely. Okay, so you can count there 1, 2 and 3. These are the 3 years that the plant actually work, and then you have to interpolate the results to get the value for $150 million. Okay, so the same thing it has been done here. So the year 3, in which you have recovered $122 million, and then here you have used the interpolation formula, in which you compare minus 67.69. Okay, so this one is basically minus 67.69, and then you have to add on this one the $40 million, which is the working capital and the land, and then you have to divide this one with minus 67.69, the same amount that you get here, plus 35.16 that you can see here. Okay, so this will give you the value for the payback time in terms of the years. Okay, so from here what we see here, 3 plus, this is a factor that we have calculated from the interpolation, and in the time of 3.85 years you can have the payback time of 3.85 years. Okay, now we have to calculate the cumulative cash position and the cumulative cash ratio. So the cumulative cash position we have calculated here, that comes out to be 170.50 million dollars. So we have to simply put it here, 170.50 million dollars. Now the this one cumulative cash ratio, we have to add the positive cash flows divided by negative cash flows. Okay, so you have to go to the cash flows here. Okay, so this one is the cash flow. So these are all the terms for the positive cash flows without the bracket signs, and these are the terms with the negative cash flows with the with these brackets. Okay, so we have to add them together. So the sigma positive cash flows on the numerator side, and then divided with the negative cash flows in the denominator, and you can get the value 1.897, which is the CCR. Okay, so if it is greater than 1, you can have the good feasibility for the project. Okay, and now we have to calculate the rate of return on investment. So the equation that can be used here. Okay, so this is the equation that we have to use. So average annual net profit divided by fixed capital investment minus 1 by n. Okay, so what we have to do here, so this one 38.25, and we have to take it this one 30.25. Okay, so you have to see this one is a factor here that we have to see, which represent you the annual net profit. Okay, so this one is the annual net profit, because we are calculating it from the revenue, and we are removing the cost of manufacturing and the depreciation. So this is the table that you have to use. Okay, so you have to get the revenue, you have to get the profit from the sales, and you have to add them all together, and then you have to divide it with the 10. Okay, because we have to take the average here, so you have to add them together and divide it with the 10. Then you have to divide it with the fixed capital investment, that is $150 million. Okay, and then on the right hand side of this equation you would see minus 1 by n. So 1 by n and represent with the number of years for the operation. Okay, so that is 10 years. Okay, minus 1 by 10, so that will give you 11.4% rate of return on investment per annum. Okay, so this is an equation that you can use, or you can actually use this equation, which is by using the same procedure. Okay, so 32.05, so this is a factor that you calculate after taking the average. Okay, and then you can divide it with the $150 million minus 1 by 10. Okay, so you can use this equation, or you can use this way, whatever it is easier for you. Okay, so now you can see this one, we have used like payback time, cumulative cash position, and cumulative cash flow ratio, and rate of return on investment for the non-discounted after cash flows. Okay, so this is one way of doing the feasibility analysis, and next time we will start with the discounted profitability criteria, and we will see that what are the new terms that we can add into the equations. Okay, so please let me know if you don't understand anything. Thank you.